It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient cratons around the world. They mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that cratons might not be as indestructible as they thought. Some cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has three main parts: the Western Bloc, the Eastern Bloc, and the Trans-North China Orogen, a zone that lies between the two blocks. Scientists found that during the Mesozoic era, the Eastern Bloc lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes, but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure, and that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the Cratons, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists looked closely at their chemical makeup, they realized the age of crystals matched the rocks found in Greenland, not Scandinavia. They used special techniques to analyze elements like uranium, lead, lutetium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other. If there were cataclysms on Earth every 5 minutes, living conditions on our planet would be almost the same as 4.5 billion years ago. Back then, seas and oceans boiled, lightning struck everywhere, tectonic plates changed their shape, lava flowed from volcanoes, and worse, no internet. The Earth resembled a vast boiling cauldron where life was gradually being created. If it starts to boil again, this cauldron could destroy almost all life on the planet. Consecutive cataclysms. Won't hurt to pretend. Let's imagine, shall we? Good morning! You wake up in a small underground bunker. The seismic sensor indicates that a 7-point earthquake will start in a few minutes. You pack a huge waterproof backpack and go upstairs. The underground bunker is protected from seismic activity. It moves with the ground, so you're safe here. But you need to leave the shelter because supplies are low. Also, yesterday, you picked up a radio signal telling all survivors to go south immediately. The coordinates they gave aren't far from your location. You have to hurry, though, before the landscape changes again. You open the hatch and find yourself in the middle of the desert. The sun is almost invisible beyond the gray sky. The ground is shaking, but you're not afraid. There are no houses or buildings, nothing to fall on you. You keep your balance perfectly, and the earthquake doesn't knock you off your feet. It's like jumping on a trampoline. The only danger is the deep chasms in the ground, but you can easily jump over them. After such an extreme morning warm-up, you decide to have breakfast. You take a tin can out of your backpack. You have a few minutes before the next disaster, so you eat and remember how your great-grandfather told you how all this started. Before all of this, the planet was divided into territories called countries. Millions of people lived in them, and then something terrible happened. The tectonic plates started to move, and the air temperature and atmospheric pressure began to rapidly change. In one day, earthquakes destroyed entire cities. Tsunamis and floods washed away the remaining ruins. Volcanic ash blocked the passage of sunlight. Forest fires destroyed almost all vegetation, and eruptions poisoned the air. Only a few people managed to adapt to such harsh conditions, and you are a lucky duck to be one of them. As you finish your breakfast, you're distracted by another ground tremor. Time to move on. Many people travel around the world alone, as they consider it a safer way of life. Some people form small communes, but no one ever stays in one place for too long. Your whole life is in motion, but you don't panic. One of the main rules during natural disasters is to remain calm, so all survivors have steel nerves and excellent physical training. You run a few miles south and suddenly smell something strange. You put on a gas mask. The earthquake has created a limnic eruption. Natural carbon dioxide is released from the ground to the surface. You feel comfortable in a gas mask, but can't run fast while wearing it. Far up ahead, you see a green forest, a rare place that was not affected by fires. You take off the gas mask and go to the tree to take shelter in the shade from the scorching sun. This green area is rich in vegetation. Colorful flowers, strawberries, and many other berries grow here. But you're concerned. Such fertile land comes from being near volcanoes. It spews underground magma rich in vitamins and minerals, so vegetation grows. You can see a high mountain in the distance. This is the volcano. An underground push occurs again and provokes an eruption. You gather strawberries and run away from this place as far as possible. Lava pours from the volcano's mouth and makes a fire in the forest. You unhook a folding scooter with a motor from your backpack and drive away from the fiery mountain as fast as you can. The sky is covered with volcanic ash, but this is not for long. A strong wind grows with each passing second. You realize a hurricane is moving in your direction. You take out a small shovel and dig a hole in the ground. The soil is dry, but you have enough strength to dig a small ravine in a couple of minutes. You dive into the shelter and cover yourself with a protective tent. The hurricane blows the volcanic ash in different directions, and the air becomes clear again. But the fire doesn't stop. The wind spreads through the forest. You get out of the ravine and put on the gas mask again. There's a lot of smoke around, and it's unbearably hot. You know the hurricane couldn't just appear without any reason. Hurricanes are formed when warm, moist air collides with the sea surface and rises to the sky, so there's water nearby. Great, because you're thirsty and want to cool down. A loud sound erupts behind you. You turn around. A massive wave of water approaches the fire. Without panic, you take your life jacket out of your backpack, remove your gas mask, and put on a diving mask and fins. The wave blows you off your feet, but you don't drown. Over the years of survival, you have learned to swim very well. You grab a passing tree and wait patiently for the flood to be replaced by another natural disaster. For 5 minutes, you sail under a black, stormy sky that sparkles with lightning. Despite the waves, you try to row south. It's getting pretty cold. You finally see the shore, but this is not a land, but ice. A strong wind brought a cold cyclone, which caused a fast temperature change. It's like you're in Antarctica. Snow and blizzards are all around. It's freezing, but you take out a thin space blanket made from foil and walk slowly south. Under your clothes, you put crumpled paper, bubble wrap, pieces of cotton. All this also helps to warm your body. Along the way, you collect several bottles of snow to melt later. Icicles form on your face, and you can't see because of the snowstorm. Suddenly, the snow begins to squish under your feet. The ice melts and turns into water. A hot stream of air blows into your face. You find yourself on hard, dry ground, looking up at the sky, then at your watch. 5 minutes pass, and the sky is again covered with black clouds. You take a metal plate out of your backpack and cover your head with it. A few seconds later, you are hit by heavy rain and hail. Giant balls of ice knock on the metal shield, but you go calmly and even with a smile on your face. The ground becomes wet and loose from icy rocks. When the hail ends, you pull out all the heat-insulating materials from under your clothes and hide them in your backpack. Then you lay out a few long spokes of steel. The spokes are wrapped with copper wire. You connect the spokes to each other, making one long antenna. You stick it in the ground and run away. After the hail from the rain clouds, lightning strikes the ground. More precisely, it hits the lightning rod you've just built. You wait for the storm to end, then take the lightning rod apart and return it to your backpack. An intense heat begins. You drink some melted snow and break your way through the desert. The earth trembles, and your adventure begins again. Earthquakes, carbon dioxide, fires, floods, snowfall, tsunamis, lightning, and again and again and again. With the help of a compass, you continue your journey and reach your goal a few months later. You see a long antenna sticking out of the ground. This is a place mark for entering an underground city. The city is built from dozens of massive bunkers connected to each other by tunnels. The city walls don't allow radiation to pass through, and they don't bend from daily earthquakes. People learn to extract energy from the ground. The Earth's core gives heat. This heat boils water, then steam is formed, and electricity is created at special stations. People get water from underground lakes and rivers. Instead of the sun, ultraviolet lamps are installed everywhere, which provide people and plants with necessary light. Natural disasters happen on Earth every 5 minutes, but humanity still has a lot of space underground. You wake up, gasping for air, struggling to peel yourself from your bed. When you do manage to get your feet on the ground, it feels like they're glued down tight. You're twice as heavy. It feels like you're carrying another you on your shoulders all day long. Well, congratulations. You've woken up on an Earth where uncontrolled experiments with dark matter have doubled the force of gravity. Mass panic happens when over 8,000 aircraft fall as soon as the gravity spikes, crashing into buildings, forests, and oceans. And that's because airplanes suddenly lost the balance between the pull of gravity and the lift force necessary to keep them cruising. Pilots did attempt to save their planes, but GPS failed as satellites swiftly moved. After a month, humans begin to look more and more like chimps. Bones are getting thicker, and the immense force constantly pulling people down is squashing their spines, making everybody bend over. People start figuring out that walking ape-style on all fours helps with better balance and stability. And that becomes a big deal, since even tripping over a tiny rock could lead to a nasty fracture. Falls not only get more intense due to the extra forces on bones and joints, but they also happen faster. Gravity's pull doubles the acceleration force, increasing it from 32 feet per second to 64 feet per second. Your house is not a safe place anymore. Old buildings and bridges all over the world are now collapsing. Inside those still standing, residents get the scary feeling that the whole place is shaking, and cracks start showing up everywhere. It's dangerous to stay inside houses, as roofs are now twice their usual weight, and any rain or snow also feels twice as heavy. Car alarms are constantly going off because tree branches keep falling all over the place. Most trees simply can't bear the weight of gravity, and only strong and small plants survive, like cactuses and succulents. 6 months after the sudden change, supermarkets have a sinister vibe going on, with shelves nearly empty and people arguing over the last loaf of bread. You get frustrated to see that your favorite Japanese restaurant is now 5 times more expensive. And it's not just about salmon prices. It's rice that has become a rare luxury item, since the gravity boost has messed up the photosynthesis process, and the seeds are taking too long to grow. On the flip side, carrots are now cheaper than ever. They're sprouting and growing at lightning speed. People start eating so many carrots that human skin now has an orange glow from all that extra beta-carotene. Farmers are getting creative, using artificial supports to keep plants like tomatoes and corn on their feet. But even with all their efforts, it's hard to get a good harvest. Summer has arrived, and even your air conditioner can't relieve the unbearable heat. A sudden change in gravity disrupted Earth's orbit around the Sun, pushing it into a new, tighter elliptical path. Earth now passes much closer to the Sun than it used to, making your sunscreen simply surrender. The Moon's orbit has also had some dramatic changes, leading to more dangerous and extreme tide patterns. High tides are now higher and low tides are lower. This shift has also triggered widespread volcanic eruptions and earthquakes on an unprecedented scale. Earth's crust starts to rupture across vast areas, unleashing planet-wide lava flows so intense that living on Venus begins to sound like a pretty good idea. 5 years later, people notice that puppies are begging for food twice as much, but they are taking more time to grow. Breeds like beagles look thinner and their leg bones are getting heavier. Even insects, such as locusts, now have thicker hind legs to keep those jumps going. Sea creatures are being crushed by the much greater weight of the water around them. That's not a big deal for animals used to deep ocean pressures, like the anglerfish, but crabs and lobsters are really struggling since they live in shallow waters. Sloths and monkeys develop a stronger grip so they won't fall off trees. For carnivorous animals living in jungles or savannas, life is a real challenge because any animal the size of a wolf or bigger can't run without breaking a leg. Large predators like lionesses are starving because they can't move fast enough to catch their prey. Tall trees like palms and pines also go through evolutionary changes. They get beefier trunks and only grow about half as tall as usual. This way, water and nutrients can travel from the ground up to their leaves without struggling against gravity so badly. 10 years have passed since gravity increased. Airlines have finally made changes to prevent commercial flights from nosediving. The wings of airplanes are now longer. Pilots have learned to fly at altitudes twice as high, and flight speed has increased by 41%. To avoid people getting extremely nauseated and dizzy during takeoffs and landings, seats are now fully horizontal, like first-class bed-like setups, specially designed to minimize the nasty effects of gravity times 2. Flight attendants are trained to raise the seat at the passenger's feet after they pass out, so that blood can return to their head. The thing is, when gravity gets a power boost, it yanks your blood down to your feet and hands even more than usual, making your heart work extra hard to pump that blood around, especially to your head. 50 years have passed. Women in their 30s look like they are 60. Higher gravity decreases collagen synthesis, so even though they're still young, they're dealing with more wrinkles and fine lines, and their skin has already lost a big part of its elasticity. Wounds as small as a pimple pop or a paper cut also take much more time to heal. So people are excited about the creation of a Band-Aid made from fish skin from cod or tilapia that promotes local blood circulation and speeds up the healing process. People have also got used to wear exoskeletons made of titanium, which support and enhance the wearer's strength. This technology features cool joints at the places that copy humans' natural movements, giving people more flexibility and letting them move around more easily. Prototypes of personal flying devices start popping up after 100 years. The Gray Flyer is like a jetpack made of carbon nanotubes, making the structure strong without adding much weight. Instead of using fuel for propulsion, the device has these super-thin but high-tech solar panels. Investors are still not sure if humans could fly long distances with it, but the Gray Flyer definitely can help people tackle tasks that have become almost impossible, like climbing a mountain or grabbing something from the attic. Things at the gym are pretty different too. The anti-gravity treadmill is a favorite among fitness enthusiasts because it uses air pressure to lift users, reducing the discomfort of gravity while running. People can also lift weights in booths when the gravity settings are customized. When training with G-force set at 3 or 4 times the new normal, muscles get stronger, making double gravity seem more bearable. However, the maximum set is 4.6. Otherwise, bones might crack. Over 500 years have passed. Thanks to these amazing technological creations, humans can now handle and establish colonies in other parts of the universe. A popular choice for family vacations is Kepler 452b, a planet about 60% larger than Earth, orbiting in the habitable zone of a sun-like star. Kids especially like that place, as oceans have been discovered and hotels have been built near rocky beaches. On the other hand, traveling to places in the universe with lighter gravity is like going to an oasis of tranquility. So Mars and the Moon have become known for amazing yoga retreats. With their gravitational forces much weaker, people can breathe more easily there and move around with more freedom. Keep in mind that these trips are expensive, so you might want to start saving up now. The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. If you live in a hot spot for earthquakes, like I do, you may have had these familiar shaking feelings. The ground trembling underneath you, pictures rattling on the walls, your neighbor's dog yapping across the yard. An earthquake is basically tectonic plates moving and grinding against each other. Rub your hands together really fast right now. Things heating up? That's energy. When these plates' energy get released, you and your neighbor's dog feel it on land. Yes, we're all surfing on giant pieces of land floating on hot liquid rock. You're surfing right now while watching this video. Sometimes one slides under another, like reaching in between the couch cushions for that remote that slipped down there. If you're wearing long sleeves, they get rolled up on your arm like a snake shedding its skin. When plate tectonics do this, mountains form. But let's zoom out from your bedroom. Even further. Keep going. There. Earth, the third planet from the Sun, covered in mountains, canyons, and those familiar continents with oceans stretching between and all around them. But our planet used to have just one single supercontinent, Pangaea, where all the land masses were hugging each other and enjoying the sweet life surrounded by one massive superocean. Africa and Australia were neighbors. The Americas and Asia popped up for a howdy neighbor. But fast forward about 300 million years, and here we are. And there you are, hanging 10 on molten rock as the ground beneath you forms mountains, ridges, volcanoes, and earthquakes. Sounds hardcore, but you don't feel like you're moving, do you? You also don't feel like your body is going highway speeds when you ride in a car. That's physics, and it's a funny thing. Right now, the plate under you is only moving a couple of inches a year, up to 4 when things get super speedy. Per day, that comes to half the width of a strand of hair. So let's speed things up a bit, say 300 feet a day. And me too.
You're sitting in your room enjoying a delicious cup of hot cocoa, scrolling the feed and watching some videos. As you set the mug on the nightstand, you begin to feel dizzy, like the room is spinning. You check your drink and see the liquid inside is swaying like crazy. Uh-oh, now you're swaying. You manage to get up but can't keep your balance. Everything topples over like a tornado in the room. You duck underneath your bed and cover your head. There's a power outage, and now you can't see anything.
There are 2 things to keep in mind when it comes to earthquakes: magnitude and intensity. Magnitude is the size of the quake. It's just one constant number. Intensity is how much shaking it causes. That number can be different depending on where you're measuring from. The most powerful earthquake ever was in Chile in 1960. Its magnitude measured 9.5 on the Richter scale. Above 7 is considered severe. The quake caused tsunamis all the way to Japan, Hawaii, the Philippines, and even New Zealand. The damage cost millions of dollars in repairs.
In the dark, you can still feel the ground shaking below you. And since the crust cut across 300 feet today, the ground rips open. The landscape where you used to bike around is now sprouting deep earth rocks and minerals. The buildings all around begin to collapse, but luckily, you manage to sneak off and escape into an open space. There isn't any service on your phone either. The cell towers toppled over during the quake, but the ground is still shaking. And with the plates moving so fast, the Earth's interior begins to show its true colors. And that color is red for red hot. You can see the mantle at this point. The Earth, like an onion, is revealing its layers. With magma flowing right in front of you, you'd think you're in a disaster movie. Suddenly, you get a whiff of salty sea air, and now you're standing on the beach. But wait a minute, you don't live by the coast. If an earthquake's strength is measured by magnitude and intensity, this one's a doozy. It probably originated out in the ocean and stretched all the way inland where you are. It caused a tidal wave so big, the coast just came to your landlocked town. Waves of ocean water are gathering near the edges of the city. Farms and rivers are all gone with a single tidal wave. The land that was good for agriculture is no more. And as the ground below you keeps on cutting, it lets in some ocean water between the gaps. It collides with the magma that's rising. Steam shoots up from the ground, and the Earth looks like a giant tea kettle. With the power out and no cell signals, there's no way of communicating with anyone. And that's just the thing with earthquakes. They can show up with hardly any warning.
Unlike earthquakes, tornadoes, and typhoons, with those, we can predict their path and intensity. We can prepare. Even volcanic eruptions give people enough time to evacuate and reach safe ground. But earthquakes are just in a league of their own.
And with all the buildings collapsing around you, you'd be seeing a smokescreen of dust and debris. The air would be unbreathable. Better grab a gas mask. Off in the distance are the mountains you've always enjoyed. You trekked along the trails every other weekend and had some fantastic camping trips along the river. But the earthquake drags across the center of the mountain and creates enough pressure to cut it. Trees start falling over. The mountain becomes a pile of rock and dust. It's not over yet. The shaking ground makes large pieces of land and rock slide down and head towards the town. Some landslides are so massive, they're enough to wipe out entire villages in remote areas. Many come after heavy rain, others come completely unexpected. With the ground opening beneath you, many of the objects on land get swallowed into the pit. Cars, trees, buildings, statues, you name it. You're able to find safe ground, but you can't really know if it's all that safe. All this is happening in your town and places across the globe. But it's about to get even more global.
Plate tectonics are crucial for life on Earth. One of their main duties in a thankless job was maintaining the planet's comfortable, livable temperature. Without landmasses floating around on a layer of liquid rock, there'd be no life on the liveliest planet we know so far. A couple of billion years ago, Earth was just a little ice ball. This was because the sun, much younger back then, was colder than it is today. You'd think the oceans would be frozen and good enough to skate from the Atlantic to the Pacific, but they weren't. And it's all because scientists believe the shifting plates underneath kept the oceans warm and cozy. They did that by creating underwater volcanoes. Besides lava and many gases, they spewed carbon dioxide into the atmosphere, which trapped the heat on Earth. As the sun gradually got hotter, rainfall was able to drag the carbon dioxide back to the ground and into the mantle. And this cycle was able to help the Earth maintain its temperature to host us. Gee, how thoughtful. Earth is so unique because of these plate tectonics. No other planet in the solar system can brag of the same, except for Jupiter's frozen moon Europa. It's shown evidence of moving plate tectonics within the core. And even though Venus and Mars have hot interiors, there hasn't been any sign of such activity.
As the ground continues to cut across the land, everything in sight has now descended underground. If the plates were to move 300 feet a day for a year, the entire planet's landscape would go through a total makeover. A bad one. Life as we know would cease to exist, except for maybe microscopic bacteria and a few insects that can survive such harsh conditions. The polar ice caps wouldn't hold any more ice, and volcanoes would continuously be erupting. The planet would just end up looking like a hot fireball of destruction, and maybe even burn up entirely.
Luckily, this is purely a hypothetical thought experiment. So, sit back, relax, and don't worry about the ground moving under your feet. It's taking its sweet time at a safe pace.
Woohoo!
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shockwave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the fifth largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the fifth largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground. But there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of three main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So, what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and… whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town, block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city. Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from Northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
The Earth has 3 main layers: 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought. because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shockwaves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms. that exist even at depths of 1.5 miles beneath the sea floor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
A bridge, a very helpful structure that traces back to the Neolithic times. The oldest bridge in the world, at least the one that is still standing, is the Arcadico Bridge, built more than 3,000 years ago. But there's a river you cannot cross using a bridge, the Amazon River, the largest and longest river in the world. Okay, the Nile River is actually the longest river in the world, but the Amazon wants both titles for itself. The Amazon River is born in Peru and crosses Colombia and Brazil until it reaches a massive delta at the Atlantic Ocean. Its waters travel a longer distance than Frodo and Sam, and yet not a single bridge has ever been built over it. Why is that? First of all, seasonal floods change the size of the river. During dry seasons, the Amazon is about 3 miles wide, but during heavy rains, it can get up to 30 miles wide in a few weeks. Not only that, but the flood also makes the river change its position. Now imagine trying to build a bridge in a place where the ground turns into water for about 4 months. Not an impossible task, but not the easiest one either. Now, if you look back at your geography classes, you might remember that the soil of the riverbank can be very soft, especially in the Amazon, which means it can erode and shift. Heavy rains also create marshes, a type of wetlands that actually reduces the magnitude of the floods and purifies the water. It's also home to many animals. This means that to build a bridge, part of this wetland would have to be drained, which would ruin the lives of all those animals. Besides, the foundations of said bridge would have to be deep, and that would cost a lot of money. The rain creates yet another problem for the potential bridge. It increases the river's water level by 13 to almost 50 feet. Of course, bridges have been built in deep rivers before, like the Padma Bridge, a gigantic structure with a foundation of 417 feet. But because the soil of the Amazon River can erode easily, a bridge would have to be built using floating structures, known as pontoons, and they're not helpful in a river that changes depth whenever it feels like it. Next on our list of things that are a problem to human endeavors is the Amazon rainforest. This forest spreads over 9 countries and is so big and so dense it could cover about half of Europe. This means that a bridge would almost likely connect one patch of the forest to another. A pointless improvement to the lives of capybaras and jaguars. Of course, the real users of such a bridge would be humans. Most people live around the tributaries of the Amazon River, not around the river itself, because who wants to live like a beaver at a dam? There's even a state called Amapá on the left side of the Amazon River that is completely cut off from the rest of Brazil. You could easily take your car and visit its neighbor, a place called French Guiana. But if you wanted to go to another part of Brazil, you'd have to find other means of transportation. Aside from small riverside populations that live right on the riverside, of the Amazon, bigger cities were built near tributary rivers, like the Rio Negro, which has a bridge, by the way, and the Nanay River in Peru. The bridges that go over the Nanay and the Rio Negro are the only 2 bridges over the rivers in the Amazon basin. The lack of good roads and highways inside the Amazon also makes the creation of bridges a pointless endeavor. Back in the 70s, humans had big ideas on how to explore the Amazon ever more, which is why they decided to build a highway which would cut the Amazon basin from left to right. The road, called the Trans-Amazonian Highway, was supposed to bring people to the heart of the Amazon. But it seems like the difficulties of building more than 2,000 miles of road inside a dense rainforest were not foreseen. Halfway through, the project was abandoned because it was super expensive and problematic. Nowadays, highways in the Amazon basin are always flooded, filled with holes and mud. This whole situation creates a ripple effect. People don't live near the river because it's hard to access it. The roads don't go there either, because it's hard to build them. Which in turn makes even fewer people want to settle on the banks of the Amazon River, because they have no roads to get them there. So, if there are no roads and no bridges, how do people live there? You're not gonna believe this, but the riverside population uses a very old but reliable invention called a boat. The Amazon River is fully navigable, and the people that live there use it like a road. Much like motorcycles, cars, and buses, the Amazon River has canoes, speedboats, and ferries. There's even a very specific ferry called Obidense, transporting people to the municipality of Óbidos, hence the name. Locals do everything on boats. They even have a boat hospital that floats around and visits riverside populations, and a boat bank, so you can do all your bank-related things while looking at the vastness of the Amazon. Honestly, genius invention. The downside to this lack of bridges is that it stops us from exploring the truly hidden gems of the world. In the Amazon, for example, there are over 10,000 undiscovered archaeological sites. We may never be able to dig out stuff like fortified villages, geoglyphs, and many other structures. It would be pretty neat to go full-on Lara Croft in the middle of the Amazon, but these findings are tucked deep in the heart of the forest. At the same time, only on a boat are you able to witness the crazy phenomenon of the unmixed waters of the Rio Negro and the Solimões on the Amazon River. For more than 3 miles, these two tributaries of the Amazon River flow side by side without mixing. The speed and the temperature of these waters are different, so you'll see a river that looks like coffee and Coca-Cola mixed. This awesome phenomenon is called the meeting of waters. But the Amazon River is not the only river in the world deemed bridgeless. The Congo River, the second longest river in Africa, only has one bridge crossing it. The two Congos, yes, there are 2 different countries in the world named Congo, are separated by the Congo River, and so far, no roads connect them. Also, fun fact, some geologists believe that back when Gondwana existed and the continents were all cuddled together, the Amazon and the Congo River were one river connected to each other. Another place with a lack of bridges is the east side of the Thames in London. The west side of the river is narrower, which makes building a bridge easier. There are about 33 bridges on the west side alone, but if you want to cross the river from the east side, it's gonna be a hassle. The thing is, back in the 1800s, shipping companies decided that building too many bridges over the Thames was too expensive, because this was a shipping route and the bridges would have to be taller than usual. The structure would also have to be long, since some parts of the Thames are about 1,870 feet wide. But building long bridges is not a problem per se. In Rio de Janeiro, for example, you can find the Rio Niterói Bridge, which is about 8.26 miles long. Back when it was built in the 70s, it was the second longest bridge in the world. The bridge is so long that in 2018, a girl was born while her mother was crossing it, and now the birthplace in her birth certificate is literally the bridge. There's also no U-turn on it, so if you drive onto the bridge by mistake, you're in for a long drive. So next time you feel like exploring the Amazon, remember to pack your own boat. This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the US economy and its global relations. The McDermott Caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries, like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott Caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass Mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. The mine will need about 2,000 workers who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027, and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives. You could wake up in New York, grab a bagel for breakfast, hop on a train, and by lunchtime, you'd already be in London enjoying fish and chips. What sounds like every tourist's dream could be a reality soon. Right now, traveling between these two cities usually takes about 8 endless hours by plane. But a high-speed train zipping through a massive transatlantic tunnel could make the same journey in just 54 minutes. The plan is to construct this train beneath the Atlantic Ocean, so the stations would look like those trendy underwater restaurants. Not only would you get to Europe in record time, but you wouldn't have to deal with jet lag or feel sick from turbulence. So far, this mega project sounds amazing, but can we really pull this off? Well, that's the million-dollar question. Actually, it's more like a $20 trillion question. That's how much this train and its futuristic underwater stations would cost. It's hard to imagine anyone having enough money to construct it, so specialists thought it was out of the question. But people started feeling hopeful again when Elon Musk dropped this announcement. He said not only is this kind of transportation possible, but his company could make it happen for 1,000 times less than everyone thought. Traveling between New York and London in less than an hour means the train would have to hit a jaw-dropping speed of 3,000 miles per hour. Yep, 3,000. That's about 5 times faster than the cruising speed of a commercial airplane like a Boeing 747. So, how is this even possible? Well, it's not an average tunnel. We're talking about a vacuum-sealed tube underwater, which cuts out air resistance, letting trains zip through at insane speeds. And it's not just any train. It's more like a high-tech aerodynamic capsule that levitates and moves thanks to magnetic propulsion. At least that's what experts think, since this kind of technology is already in use today with the fastest public train in the world, the Shanghai Maglev. This machine runs in China and hits a top speed of 186 miles per hour. What's crazy is that its locomotives are not even touching the tracks. They're literally levitating and floating just about 0.4 inches above the ground. This line takes people from Shanghai to Pudong International Airport, so travelers don't have to worry about traffic and can get to their flights super fast. This cutting-edge technology makes a 19-mile trip take just 8 minutes and 10 seconds. With a regular train, that same journey would be about 4 times longer. Back in 2001, people worked hard over 2 years to construct the maglev train, and they also spent a lot of money, as the whole project cost over $1 billion. Despite that crazy initial price tag, keeping this line running is not as expensive as it might seem. It's actually cheaper to operate than regular trains. Since the maglev doesn't touch the tracks, that means a lot less wear and tear and way lower maintenance costs. On top of that, its propulsion system is impressively energy efficient. As we've already mentioned, this is the fastest operational train in the world, but China isn't stopping there. They're likely to break their own record soon, having already unveiled a prototype of their next generation train, the CR450. This sleek silver bullet had reached test speeds as high as 281 miles. If this project comes to life, if people really start using it on a daily basis, it will be a game changer for high-speed rail. And it could shrink the journey between Beijing and Shanghai to less than 3 hours. That's like 1 hour less than what people take when traveling on today's high-speed train. Now, the team just needs to run a couple more tests to ensure it meets all necessary standards for commercial operations. This car looks like a Batmobile, and it's probably just as powerful. Say hello to the amazing Koenigsegg Jesko Absolute. Its sleek, futuristic design isn't just for show. Every detail on this machine was crafted to cut through air with precision, reducing drag and turbulence while boosting its high-speed performance. Experts ran the first computer simulations, and the Jesko Absolute hit an astonishing 311 miles per hour. But the team is positive that it can go even faster. This beast comes close to the cruising speed of small jets, and because of that, it smashed all records and became the fastest car in the world. When you visit the Coventry Transport Museum in England, you'll come face to face with a terrestrial vehicle that looks more like a rocket than a car. Meet the Bloodhound LSR. It's been on display since 2019, right after hitting 628 miles per hour during tests in South Africa's Kalahari Desert. But the team behind this vehicle isn't satisfied just yet, and they're 99% sure they can go even faster. So, they're planning to bring it back to the track soon, aiming to smash another record. But there's a catch. The team is still looking for a fearless, skilled pilot who can handle speeds over 800 miles per hour. And before you rush to sign up for the challenge, let me remind you, it's going to take more than just guts. You will need a major sponsorship deal too, because getting back this vehicle on the track and breaking that land speed record could cost around $15 million. If you're curious about the fastest jets in the world, look no further. Meet the North American X-15, a legendary aircraft that flew for nearly 10 years and set an unofficial world speed record of 4,520 miles per hour. This beast is so impressive that it actually reached the edge of space during its test flights in the 1960s. Yep, astronauts territory. To put that into perspective, commercial airplanes, like the ones we fly in, usually travel at altitudes of up to 42,000 feet, but the X-15 soared more than 354,000 feet. Now, imagine flying faster than ever before, zooming through the sky at over 5 times the speed of sound. That's exactly what NASA did with this revolutionary aircraft, known as the X-43A. This airplane is scramjet powered, which basically means it's an engine that operates at a supersonic level. I mean, it doesn't have any moving parts like regular jet engines do, like turbines. Instead, it uses the plane's speed to push air into the engine. The air gets compressed or squished by the plane's fast motion, then mixed with fuel and burned to produce thrust. For non-experts, this might seem crazy, even dangerous. In fact, we should mention that the first flights of the X-43A weren't exactly smooth sailing. The initial attempt happened back in June of 2001, but the airplane was destroyed after the booster rocket went out of control. Thankfully, the second and third attempts were a huge success, with record-breaking flights that made history. I know elevators aren't the first thing that comes to mind when we think about super-fast means of transportation, but it's only thanks to ultra-modern high-speed elevators that skyscrapers as tall as the Burj Khalifa and Taipei 101 became accessible. One of the fastest elevators in the world is located in the Shanghai Tower in China, which has 128 floors. To get people from the ground floor to the top of the building quickly, the elevator has to move at an incredible speed of 67 feet per second. That's faster than Usain Bolt at his top speed, but just a little slower than a cheetah. Still, it is super fast, about 5 times quicker than the elevators we ride in most buildings. So if you're afraid of heights, speed, and tight spaces, we suggest you avoid going that far.